So here on this stand booth we show you the complete process for building a production line. So that starts from the very beginning when you start the layout. Then we show how you do the access. Let me go to this side here. You do the access programming, of this line, all on the virtual model. You do the operation, the programming of it, and you do the testing, the real behavior testing of this line, even before the first screw, and you even touch the hardware for that. Then, on the next process, we do the optimization for this line in terms of really model calibration, which is exactly supposed to be really exactly the behavior of the machine. Then we do the monitoring of the line through the complete process, where we find, and if we find the deviations in terms of behavior of the machine, we can take corrective actions. So let me start here. Just showing you with the layout. We're starting with the layout of the machine. So actually, what we do, you look at going to what we call the marketplace, part supply marketplace, where you look for elements, for example here from Bosch Rexroth, that you can configure online with different parameters on it. So you look for the right equipment to build the mechanical layout, and rather than only importing CAD model, what we show here is that you insert it directly into the CAD system with all the behavior modeling behind it. So it's not only the PDF file and the step file, you really insert it directly into CATIA V6 with all kinematics predefined, with Modelica libraries that define it for the further usage. Let's go a little bit ahead. So you create your different elements of the line. Accelerate a little bit. And you position your line with the different elements into the factory, right on the layout plan. So you see, we have the one that we just defined. Okay, go forward. And now we build the complete line here on this layout. So we attach the different modules that we have for the line. So you have the robot module, you have a module where you do the housing, you do a screwing, you have a roboter module, we have a laser module, etc. So we fit it together, creates a line layout in several steps, and then do what I just said before. We do the details on the access programming, the behavior, and how the machine, the components, the different modules work together. So that's really getting there. So you define, it's not only kinematics again, but you prepare for programming of the complete line, the behavior of the line, and you test it, how these different components work together. So what we're doing here as well, so we have the different components. So you have the layers, you have the modules that we put together. Now we are really going into the programming of the complete line with product control build, where you test the logic of the machine, how you get it really together to make sure that it works in the end. So every single position. What is the important thing here is that based on the 3D Experience platform, we really have all the data that we created on the 3D Experience platform. It's not only the CAD data that we started, but the complete process. We just jumped into the complete process of building a line. You have in the system, on the platform, within one data model, you have the 3D, you have the requirements, you have the functional description, you have the logical description, and the physics behind it. So coming from here, as well, you use it for creating the line. So we prepare everything in the virtual environment to make sure that it works when you really start getting the line together. So what we're working on is in the next steps here, that we couldn't show it here, is to do the auto programmation of the PLCs of the line, so that the code is automatically generated from these virtual definitions. We do even more. We have the sensor data. So with the sensor data, in this example, we work very close together with Bosch Rexroth as an example, and Bosch Rexroth has a device called IoT Gateway. The IoT Gateway is there to collect the information, all the sensor data on real time, to filter the data, to secure the communication with a data lake, which could be Azure, which could be any other cloud-based systems, and to make sure that all this information really is available. And what we do here in the first step, before the hardware, we create digital data of the sensor data from the simulation. So you are capable of comparing this first virtually created sensor data later with the real data. So that's very important as well. So that means that we will have the possibility, once the line is operating, to always compare and monitor. And if you find derivations of the system, then we can look and dig into more detail. How do we do that again? So we have another product called Exelite. So Exelite is monitoring on this part as well the possibilities of. Sorry. Thank you. So from here with Exelite, we are doing analysis on the sensor data in the data lake to identify the issue. So because we have possibilities to see there is a derivation from the sensor, but we have to take corrective measures. So that means from here we really start and say, with this we help dig with Exelite into the sensor data, identify all the information, and use the different information coming from all different systems. So the sensor data, the development data, the manufacturing data, the production data, whatever it is, where is it installed, which customer has what installed, to make sure that we can take the right decision to take these corrective actions. And then once we do these actions again, we go back and do in the virtual model, we have the corrections we apply the correction in an engineering change to the system and make sure that the line and the virtual model are always in sync. That's what I personally call digital twin. Not as very often we're talking in the industry about the digital twin, meaning that we collect sensor data and build up the virtual reality afterward. For me, this is just a virtual mirror. So we are really talking about the virtual twin here in this case. So we can go into much more detail about every single step of this, but I think from a first level, the high level overview, if you have questions, please don't hesitate asking them.
Hello, welcome to our flexible and manufacturing with predictive maintenance experience. What we're showing you today is a full experience that we've done in Dassault Systèmes through the experience platform. We're starting by grabbing the data from our machines, from our IoT sensors, using our Delmia Priso software. We also use and work with our OSIsoft partner to grab the data. So the challenges here are how to capture the data, how to store the data, and how to analyze the data. Once done, of course, we can monitor the operations and the machines within a Priso Delmia. And we will, within the same platform, we will have the capability to learn more and to predict the new failures. And now in the story, I'm showing this Exelite machine learning and predictive analytics. What we are doing, we are using the big data. We are using all the data coming from the platform and coming from our other softwares to predict the future failures. Because we are using one single 3D experience platform, we will, once we predict a new failure, we will give a task to our colleagues within the platform, within Delmia or Temps, to schedule and to execute an action. So please come with me, I will show you here one application which is called the Manufacturing Analytics application. So the purpose of this application is to help the user as, let's say, I'm the factory's manager. I will need a tool, a smart tool, to predict the failures and help me having an action. So here you can find on the left is the list of all the predicted future failures. Let me first explain how we can have this kind of view. Of course, we need to have a lot of data. Here for this experience, we were working on 79 machines in six factories in the world. So of course we have a small, at the beginning, analytics, KPIs, capabilities, which will enable us to drill down and to analyze better our factories. So here I'm filtering on one factory called Transmission Equipment Shanghai. I want to have a better view on all my analytics and KPIs within this factory. Here I can see the major KPIs, the overall equipment efficiency, the performance, the quality. I will continue to analyze, I will to drill down on the work center which have the lowest efficiency ever. And I can see within this KPI that this one is the lowest. So what we can see now is we selected the work center which have those 3 machines which we have a decreasing efficiency. Because we are historizing the data, of course we can compare the efficiency before and the efficiency now. So once we have that, I will move to my detailed view about each machine to understand better how it's working. So here I'm zooming on one machine called 5-ax machine, and here the magic will start happening because we're grabbing the data from everywhere. So we're grabbing the data from our Appraisal tool, which is the tool which enables us to monitor the operations and the maintenance. So we have here some events, the setup, running, downtime, etc. Better than that, we have some graphs which will show us the real-time data coming from the sensors, from the machines. In the red, we will have the old failures that we have in the past months, years, decades. And in the green, because we have a big data factory and we can use our machine learning algorithms to learn from those failures, we are using the deep learning to give a fingerprint to each failure and to predict the future failures. So what you are seeing here is an example. We are predicting a new failure that will happen now. Because we are using one 3D experience platform, we can use the virtual world and combine it to the real world. So here what you are seeing in the blue is the data coming from the simulation world, and in red you will see the real world coming from the sensor. So it will enable us to have more detailed views to compare the virtual and the real world. So as a facility manager, I want to understand better this prediction. I will click on it. I will have more details about those predictions. So of course I'm predicting a new failure, but better than that, I will recommend some action for my users, because we are giving some fingerprints to each failure. So we will help the user to have the similar old failures, and we will recommend one action to our operators. So let me give you maybe 2 takeaways. First, we are using one single platform, which is the 3D experience platform. We have a digital continuity within all our workers, the designers, engineers, manufacturers, operators. So we are learning and we are also closing the loop. So we are learning from the real world and putting all the information into the virtual world. And because we're starting combining the virtual and the real world, we are ameliorating our products each day.